The next set of transformations that we're going to look at are reflections, and these occur when you apply a negative sign to a basic function. When we look at example C, the basic function which is closest to what we're given is the square root of x, and so we're going to compare to that basic function which we've graphed before. F of x is equal to the positive square root of x. And that graph looks like this. And so now when we apply that negative sign, what you see is that each of the values that we calculate, the f of x or the y values, will become negative. So we start off at the origin, but the positive value of y, when y is equal to positive 1, that reflects below the axis and becomes y is equal to negative 1. And so we can graph this new function below the axis. And therefore, this function f of x is equal to negative square root of x, again as a mirror image reflection of f of x is equal to positive square root of x. We see something similar with the absolute value function. So for f of x is equal to positive absolute value of x, we can graph that function, and it has this V shape. Now when we want to graph f of x is equal to negative absolute value of x, again, all of the y values take on negative values. So the point positive 1 reflects down to 1, negative 1. And the point 2, positive 2 reflects down to the point 2, negative 2, and so on. And we get the upside down V. So you can note that every point on the original graph of f of x is equal to absolute value of x has a corresponding point with a negative y value for the function that we're given, f of x is equal to negative absolute value of x. Next, we're going to look at y-axis reflection, which goes in the other direction. This time we are reflecting from left to right rather than from top to bottom. So we're going to take a look at this function, square root of negative x. And this time, observe that the negative sign is on the inside of the radical, which means that it's on the inside of the function, close to the x. And that is in contrast to the minus sign, which is on the outside of the function for example C. When we draw our original graph, it looks like this. So again, this is the graph of f of x is equal to the square root of positive x. But now, the negative x is going to cause the graph to reflect to the other side, and so it's going to be drawn in the second quadrant. And you can see that this is a mirror image reflection, this time reflected across the y-axis. Now, if you're not confident that this is how the graph should appear, you can always plot points. So we're going to choose some different values of x and calculate the corresponding values of y. And because of this minus sign on the inside of the radical, we need to choose values of x that are negative. If we chose values of x that were positive, for example, positive 2, then we would be taking the square root of a negative or opposite of that positive 2, which would give us an undefined number. So again, we'll pick some values for x such as negative 1 and say negative 2, and then do the calculations here. And then when we calculate f of x, we're going to see that the square root of a negative 1 is positive 1, and that's just going to be equal to 1. So when x is equal to a negative 1, then y is equal to a positive 1. Now, when we choose x is equal to negative 2, again, we're talking about the square root of a negative 2, which is positive 2, and square root of 2 is about 1.4. And so we can go out to a number which will give us a perfect square, perfect root. We've got square root of a negative 4 is square root of 4, and that gives us 2. And so we have the point x is equal to -4 and y is 2. And you can see that these points do fall along the curve that we've drawn. Finally, let's go over to the last graph, which is also using an absolute value, but this time the minus sign is on the inside of the absolute value symbol. And our absolute value graph looks like this. So this is f of x is equal to just the absolute value of x. And now, according to this principle here, that if we put a minus sign inside of the parentheses, that we should be reflecting across the y-axis. But if you look at this point over here, the point 6, if we reflect it across the y-axis, it will go on to the other side. It will reflect and become the point -6. And we have an interesting result here, because what we have is that the right-hand side reflects onto the left. And so we can draw the graph here, but then the pink on the left-hand side will reflect over onto the right. And so our reflected graph is identical to the original graph. When this occurs, we call this y-axis symmetrical. That is, that this particular graph, the absolute value of x, is symmetrical from left to right when you reflect it across that y-axis.